Welcome, everybody. We have a great deal of interest in our program today. Thank you all for joining. My name is Carl Zimick, and I recently rejoined the ProDairy program as a dairy climate leadership specialist. I'm happy to be back and happy to introduce two excellent speakers here this afternoon to talk about nutrient management tool as well as a carbon footprinting tool that the team has been putting into place on farms. And we're going to have our first speaker is Dr. Quirine Ketterings. She's head of the Nutrient Management SPEAR program at Cornell. Many of you are familiar with Quirine, and also Dr. Olivia Godber, also part of the SPEAR program. And they're going to tag team this, and Quirine's going to start, and then Olivia is going to talk a little bit part way through. So Q and Olivia, please take it away. Thanks.
All right. Thank you, Carl. So Olivia is going to be in charge of advancing slides while I get started, and then she will take over halfway through our presentation. Start out with the topic here, quantifying nutrient balances and greenhouse gas emissions from dairy farms. The outline for our talk is we're going to start talking with you about sustainability tools and what makes a good whole farm sustainability tool, and then present on two specific tools, the whole farm nutrient mass balance as an example, with an update on what the current status is. And then Olivia will talk about Cool Farm tool as an example of a sustainability tool for greenhouse gas emissions and a few other sustainability indicators. We'll close out with integration of tools and how we can get added value from those assessments. So our data sustainability project that Olivia is heading up within our team, our approach is to work directly with farms across New York to determine sustainability key performance indicators, KPIs. Things that we can measure that allow farms to compare to others and to monitor progress over time, so compare to themselves over years. And we're looking at the whole farm level. We're looking at nutrients, we're looking at greenhouse gas emissions, and we're also beginning to look into above ground biodiversity. We always want to keep in mind two goals, environmental and economic impact, with the ultimate goal that we want to identify key performance indicators that can help a farm minimize nutrient loss, minimize greenhouse gas emissions, enhance biodiversity, and ensure economic success. Why do we need sustainability tools? Well, most of you will be aware that US Dairy has made some commitments, environmental stewardship goals for 2050 or 2050. That includes these three here: become carbon neutral or better, optimize water use by maximizing recycling, and improve water quality by optimizing utilization of manure and nutrients already on the farm. In addition to this, there's increasing pressure from other stakeholders to report sustainability metrics, and we're particularly looking at the processors, retailers, consumers that want to know what our carbon footprint is. They want to know how efficiently we're producing our food. And with all of this comes market competition. We have a focus on whole farm tools because we want to know what the status is of our farms, an individual farm, in terms of their nutrient use, efficiency, their emissions. We also want to have tools that can guide improvements, that can be used to identify where are the opportunities for improvements so that we can increase farm nutrient use efficiency and nutrient recycling. And we can also demonstrate good practices at the farm level. For us, it's really important that these are whole farm tools because we work with dairy systems, and in New York and the Northeast in general, our dairy farms are integrated crop and livestock systems, cropland and animals. And we have about 60 to 70% of our feed that is homegrown. And with this whole package by itself in those integrated systems, we believe we have an advantage actually. And that might be one that we can turn into a market advantage as well. We looked at tools to do this whole farm assessments back in the 2000s when I started working at Cornell and with Carl there at that time as well. And looked at what do we need to have a sustainability tool that's actually usable for us. And we came up with 8 criteria. Minimum input, maximum output. Something that requires data that are readily achievable to document, records that we can keep, and that give us maximum useful output. They should also give measures of sustainability across management units in addition to the whole farms, cows, storage, crops, soils. We want tools that have transparent calculations and of which we can understand the results, and tools that are responsive to management changes. So if a farm makes a change for the better and the tool does not reflect that change, it's not a useful tool for this purpose. We also want our tools where we have an opportunity to set targets to strive for, feasible limits. Tools that allow farms to document improvements over time and that can easily be updated as new information, new science becomes available. So not static ones, but tools that move into the future. And then the last one is really important. Tools that are trusted among dairy stakeholders, all of them, farmers, processors, retailers, consumers, policymakers. We have to have something we can stand behind and trust. With this in mind, we started embarking on our tools. So, next slide, Olivia. There we are. The two tools that we're working with right now are the Nutrient Mass Balance tool and the Cool Farm tool. And I'll be covering our mass balance tool and some updates on the current status of that. And then Olivia will take over for Cool Farm tool. So the mass balance tool, there's a bit of a process here. When CAFO came in place in 2000, all of the CAFO regulations were focused on managing the land base, how to distribute manure over the landscape to minimize losses to the environment and optimize nutrient use. There were examples from some high animal density farms with a lot of animals and fewer acres that showed the importance of also balancing animals with cropland. So not just focus on the land base, but involve the animal in a whole farm approach. So whole farm assessment tools connecting nutrition, storage, agronomy was really needed. We needed to look at imports and exports at the whole farm level. Next slide, please. And that's where we started looking at this mass balance approach. It's an accounting system. We take the farm, we draw a boundary around it. This is all of the farm, cropland, cows, storages, all of it. Draw a boundary around it, and then we look at what comes in to the boundary, across the boundary, in terms of feed, fertilizer, maybe some animals being brought onto the farm, maybe some bedding, manure being imported. On the other end, we have exports. So if it's a dairy farm, they're most likely exporting milk. So milk exports, animal, crop, and any manure exports that might happen for that farm. Then we can take the difference between the imports and the exports, and we call that the balance. And we do this in terms of nutrients. So nitrogen, phosphorus, and potassium is what we include right now. So fertilizer, define what it is that we are purchasing, how many tons, and what the fertilizer composition is. That gives us a total amount of nitrogen, phosphorus, potassium imported by fertilizer. Similarly with milk, how much crude protein is in it, how much P and K, and we can calculate what the export of NPK is through milk. Once we have that balance, the difference, we want to express that in two ways. In one way, on the left is the per tillable acre number. So we take the balance and we divide it simply by the total amount of acres on that farm, cropland. That it gives us an estimate of, do we have the land base to recycle those nutrients? On the right is the balance per hundredweight of milk. And that is more of a nutrient use efficiency indicator. How efficient am I using the nutrients that I am importing to produce the milk that I'm exporting? So two indicators. When we started developing this, we started out with step 1. We are currently at step 6 and 7. So I'm going to briefly walk you through this approach here that we took with those mass balances. So the first step, the basic accounting approach, was basically looking at this concept of, if we calculate the balance and we express it per acre and per hundredweight, we might be able to guide farms moving forward. But when we started this, we could do these calculations, but we didn't really know what it all meant. Initial participants before 2014, when they participated in this, they received a page full of numbers. It was difficult to put these numbers into context. We didn't know how to compare one farm to another. It was not easy to find out what the drivers were of these balances. And it was difficult to know if they needed to be improved. So we got numbers, but didn't know what to do with it. Then we started inviting more farms to participate, and more farms were joining in this project. And we arrived to the step where we were able to put mealing behind these numbers and set feasible balances. So here in blue are the balances per acre. In yellow are the balances per hundredweight. And then we have the balance for nitrogen, phosphorus, and potassium, and P and K. We were able to set feasible balances. That meant that if the farm for nitrogen, for example, was between 0 and 105 pounds of nitrogen per acre, it met the feasible balances. If it was between 0 and 0.88 pounds of nitrogen per hundredweight, it met the feasible balances per hundredweight of milk. So these are feasible ranges, something to strive to be within. We were able to set those based on the farm data that were shared with us up until that moment. Farmers participating, generating a larger database, looking at longer term records, carrying capacity calculations, and discussions with the farm community as well. So now we had feasible balances, started working with farms, reporting that back. And if the farm participated for a while, they would get figures like this. Here's one for nitrogen, phosphorus, and potassium, the years in which this farm participated. And then in blue, we see that range for nitrogen between 0 and 105 pounds per acre, for phosphorus between 0 and 12 pounds per acre, for potassium between 0 and 37. So if the farm dot for that year was in the blue, that farm met the feasible balance per acre for that nutrient. This allowed farms to track progress over time. Similarly, for the balance per hundredweight, very same concept, just in this case, the balance per hundredweight. Now, ideally, we would like farms to meet both the feasible balances per acre and per hundredweight. So out of these combined two indicators, we developed the green box figure. And this is the example for phosphorus. The first one shows milk production on the horizontal axis and then phosphorus balance per acre on the vertical axis. The 0 to 12 is the blue box. Then we have in yellow the farms with the efficient milk production, so the lower numbers per hundredweight of milk. And then when you overlay blue and yellow, you get green, and that's the green box, sort of the sweet spot to be striving to achieve. With these green box figures, we were now able to report back a comparison of that farm to itself. In this case, the dark red is the most current year and the lighter red is previous years. So they can compare to themselves over time. But they can also compare to all the other farms in the database, the black dots in these figures. We were also able, because of the participation of these farms, to derive what we call the opportunity table. And this is driving a little bit more into the box. You see the first two lines here are the balance per acre or hectare, in this case, metric, or the balance per hundredweight of milk produced. And then we have indicators, things like feed use efficiency, homegrown feed percentage, crude protein, phosphorus in the ration, and animal density. If a farm exceeded a certain level, it got their indicator got flagged in orange, indicating that that's maybe something the farm could look into to see if there's an opportunity for improvement in these balances. So we've been reporting back to a lot of farms over the years with these opportunity tables, allowing them to dive into a little deeper and finding out where to start looking for making improvements. If you one slide back, Olivia, 1 second. So one of the lessons learned out of the mass balances so far, key sustainability indicators, feed and fertilizer are driving the balances. Animal density is a big driver as well. If you have more animals than a cow and her replacement per 2 acres, it becomes more difficult to be in the green box. Higher animal density than 1 animal unit per acre. If you exceed that animal density, you can still be in the green box, but manure exports might be needed to be considered. All right. With this, we went to step 5, and this is a more recent assessment of what we have in terms of feasible limits and in terms of key performance indicators in the opportunity table. So we most recently, this was published last year, did another take at all the data that were gathered in more recent years and said, is the current status still consistent with the feasible limits we set. Next slide. So here's where we're at right now. In 2022, 85 farms have participated in the mass balance assessment. 21% of all the milk produced in New York has gone through a mass balance assessment. If we look at the composition of the farms, you'll see that the characteristics show a large variability in the farms, ranging from very small ones to large ones. We also see that the median animal density is 1.1 animal unit per acre. So that's a little higher than what we had in older databases, earlier years in the project. The current status for the 2022, if we look at all these farms, the red dots are the 2022 farms, for phosphorus on the left, for nitrogen on the right. If we look at phosphorus on the left first, you see the star, the big star is the weighted average for the New York farms in the database, 2022. And you will see that that red star is in the green box. The average farm in that database meets the balance per acre for phosphorus and the balance per 100 weight. It averages is 11 pounds of P per acre and 0.07 pounds of P per 100 weight of milk, meeting both blue and yellow, and therefore in the green box. That is a really good success story for us in New York. On the right is the picture for nitrogen. And for nitrogen, we see that the red star is in the yellow, but it's just above the blue. So for nitrogen, we have efficiently producing farms on average year, 0.80 pounds of nitrogen per 100 weight of milk. But our per acre number is 126, which is above the 105 feasible balance cutoff that was established. So improved, but some work still to be done for nitrogen. Wanted to emphasize with the next slides the importance of the animal density that we talked about. So the all farms is in the middle here. For phosphorus on the left, all farms 11 pounds and 0.07 pounds. If we look at the lower density farms, less than 1 animal unit per acre, so less than 1 cow and replacement on 2 acres, we see that these farms average in the green box as well. They meet both blue and yellow. On the phosphorus side, animal densities over 1 animal unit per acre are also still in the green box. But we see the numbers per acre go up a little bit with animal density. On the nitrogen side, all farms, the 126 was about 21 pounds over the limit. The farms with an animal density below 1 animal unit per acre were in the blue box. It was the higher density farms that struggled to meet those feasible limits for nitrogen. So the numbers go up from left to right, 98 to 126 for all, 144 for animal densities over 1 animal unit per acre. It's stressing the importance of balancing animals with the land base. On the good news side here for both N and P is that when you look at the yellow boxes and you go from left to right, from low animal density to high animal density, you actually see the efficiency improve. The higher animal density farms had higher efficiencies for both P and N than the lower animal density farms. We documented a couple of good news stories. One was the comparison of the early farms with the current farms. The farms that are participating now produced over 50% more milk per acre than the farms that participated early on. They also produce milk with a 36% improved phosphorus use efficiency. Fed diets with lower crude protein content, improving end use efficiency as well. Those are really good news stories, looking at the trends from earlier days in this mass balance assessment to current. Next slide, please. A quick characterization of the farms that we have in there. If you see the box in green, that's good. So on the left, the first one, the milk production per cow. In the green box, high producing farms. Feed per ton and tons per animal unit in the green box, doing great. What we see is the animal density slightly above that 1 animal unit per acre And as a result, the homegrown feed still very good with 65%, but it's on the lower end of that box. When we look at the nutrients, the drivers for the nutrients, we see that the balance per acre for nitrogen is outside the blue box. For per 100 weight, it's in the yellow. We look at the boxes at the bottom, we see feed use efficiency is good. Crude protein, percent crude protein on all feed is in the green box. Crude protein purchase feed is in the green box. We see crude protein in homegrown feed on the bottom end, on the low end, driven by the fact that the animal densities are higher, and therefore the farm needs to import more feed. And feed imports are also outside of the box. These two things go together. In terms of fertilizer, we see that it's slightly higher on the right side than the box that was established with the 40 pounds. So high nitrogen use, low homegrown crude protein. Can farms incorporate more legumes is the question here. Can we increase that homegrown crude protein so we can reduce the feed imports? In terms of phosphorus, story is somewhat similar, yet different. For phosphorus, both the per acre and the per 100 weight are in the zones, in the blue and in the yellow. Our feed use efficiency is good. Our crude protein, our percent P in all feed, purchase feed, all of that is good. We see the same trends of percent P in homegrown feed on the low end, primarily driven by P feed imports being on the high end in these higher density farms. But we also see the good news story there on the right for fertilizer imports. We have very low fertilizer phosphorus use in New York. The high purchase feed imports may also be in part the consequence of imports of high crude protein feeds, such as canola, that bring phosphorus along with it. Another good news story for us, that homegrown forages, you'll hear more about it when Olivia starts talking about the carbon footprint of the feed fed to animals. We've seen on average 65 up to 70% was homegrown feed across these farms. And it has really good consequences. It has a possibility of improving soil health, crop production, create climate resilient systems with use of manure, reduce fertilizer use when we have manure. We can implement practices to promote biodiversity on the farm base through crop rotation and management, and basically through these homegrown forages create a circular economy. So back to our 8 criteria. The mass balance absolutely meets all 8 of those. But in addition to this, it's now also recognized by the state that incentivizing mass balance assessments is a good thing to do. Farms that are regulated that can now also use their mass balance score if they're meeting the mass balances per acre for phosphorus and for nitrogen, to have greater freedom with manure applications and fertilizer use on their farm. With that, I have talked to you now through steps 1 through 5. We went from a basic concept to having something implemented and incentivized here in the state of New York. And it really begged the question, like, can we do this with other tools? And with that, I'm going to hand it over to Olivia to carry us through the rest of the talk.
Olivia, we're not hearing you for some reason. The mute sign appears to be off, but we're not hearing your voice. I assume I'm not the only one.
I cannot hear you either, Olivia.
About now.
Yep.
Yes.
Yep.
Yes.
Okay. So after we established that process, we developed a tool that is usable and useful for farmers and also gets us some good results out of it that we can use to make decisions. We wanted to replicate that for other metrics. So we focused on greenhouse gas emissions, biodiversity, water use. I'm going to focus on what we've been looking at now for greenhouse gas emissions. To do this, we've used a tool called Cool Farm Tool, and I will go into more about that tool. But first of all, I want to just sort of think about where greenhouse gases come from on a dairy farm. So similar to the mass balance, we put a boundary around the farm, and this gives us a farm gate footprint. And we have to look at things that are taking place on the farm. So we look at animal feeding and manure management. So the cow herself, the emissions she's producing, and how the manure is being stored on the farm. We also look at soil management for feed production. So how the crop practices on the farm, agricultural soil emissions, and we need to know what crops are being grown, the yields of those, how much manure and fertilizer has been applied and when it's being applied, any tillage practices, and carbon sequestration. It's also important that we look at those imported feed and fertilizer purchases, because the dairy farm is responsible for the emissions associated with the production of those products. And this means, you know, similar to the mass balance, we want to try and minimize those imports as much as possible. On the other side, any crops and animals that are sold from the farm, they will take a proportion of the emissions with them. Finally, is carbon sequestration. So this is where we're capturing the carbon from the atmosphere and putting it into a permanent store, either woody biomass or the ground. We're not going to go into too much detail on that today, but it's another greenhouse gas source that we need to consider. So there's multiple tools available to estimate greenhouse gas emissions. These range in their complexity. Some you need very little data to run them, but then the result that you get out the other end is not very informative. It doesn't help us look at differences between farms. Other tools are much more complex. They require a huge amount of data. For example, for every field on a farm, you need a 20-year history of fertilizer application dates, timing of tillage events. It's not feasible for a farm to get that information and run it, but they do have a place. They're good research tools, and they can be used to help inform other decisions. Some as well, you know, they don't get updated very often, or they're specific to a particular region. And you know, the reason we're working with Cool Farm Tool is because we think it meets some of our 8 criteria that we set before. So minimum input with maximum output. You need a fairly easy to collect amount of data. We get some good results out the other end. We can do that, measure that sustainability across the management unit. So we can break down the different parts of the farm, the feed production on the farm, the crop side, and the cows, the manure management. The calculations are transparent with easy to interpret results. So Cool Farm Tool are very good at putting out there the data that their tool runs on and the models that are behind it. And it's also responsive to management changes. So we can run scenarios in that tool. We can set feasible targets to strive for, and farms can also document their improvement over time if they do this annually. We can also, so the tool can be updated as new information becomes available. Cool Farm Tool have a very active working group and science committee who are working to see what stakeholders want to see in the tool and how we can get robust science to build those things into it in the future. And again, it's trusted among stakeholders. So I just want to show here, these are a lot of the companies that are already using Cool Farm Tool. Here are a few names that you might recognize. So again, anyone who is any of these companies that are reporting their greenhouse gas emissions, if a farm decides to use this tool, their results will be directly comparable to those. So if you wanted to take part in the greenhouse gas assessment through the SPHERE program, what do we report? So we give back the total farm emissions and emissions per kilogram of fat and protein corrected milk. That's the emission intensity. We break down the emissions from the different sources on the farm. So we break out feed production, grazing management, enteric emissions, manure management, fuel and energy use. We also break down the emissions by gas. So you can look at how much is coming from methane versus nitrous oxide and carbon dioxide. And then we can look at the progress made and your potential for further improvement. So currently, Cool Farm Tool reports on this 100-year global warming potential, but we know in New York State, we also need to consider the 20-year global warming potential. And from the results we get from the tool, we are able to provide both of these. So we had 85 farms run the nutrient mass balance assessment in 2022, or using for their 2022 year. 45 of those farms also completed the Cool Farm Tool assessment with us, which represented about 2 billion pounds of milk and around 13% of the New York milk. So here you can see the results for those farms. The weighted average result was the 0.81 pounds of CO2 equivalent per pound of fat and protein corrected milk. This was the average emission intensity of the farms. As you can see, there was a wide range going from 0.63 to 2.17. That's showing there's a lot of different outcomes currently through the farms that we were looking at. The farms that take part in this will get two figures in their report. This is an example for one of those farms. Each of these pie charts is a farm that has participated. And then within the pie chart, we break down the source of emissions. So for example, we have in red is the enteric production, yellow is their feed production, brown is manure management, purple, energy, fuel and transport, and then in the two greens, grazing and grassland fertilization. So if a farm participates, this means that they can compare themselves to the other farms that are taking part and start to identify where their emissions are coming from. So this figure in the left, we show on the horizontal axis, the total emissions for the farm in that year. And on the vertical axis, that emission intensity. So how many emissions per unit of milk being produced. And this emission intensity is the one that the industry is very interested in. So how efficiently is the milk being produced? But the total emissions is also important. We need to not lose sight of that. On the right, so we have that emission intensity on the vertical axis. And then going horizontally, that's the milk production of the average milk production per cow per year for the farm. So we indicate the farm taking part with the arrow. And again, we can track their progress over time, similar to those green box figures. On here, the solid green line, so this is that weighted average 0.81 pounds of carbon dioxide equivalent per pound of fat and protein corrected milk. The two lines we have above that are published values that we can compare to. So it's not a direct comparison. These published values use different tools, different data sets from different years, but it's the closest we currently have to compare the New York results to. So for those, we have a Northeast US average of 0.98 pounds of CO2 equivalent per pound of fat and protein corrected milk. And then we have a North American average of 1.13. So if we compare the farms that we currently have in our database, they are performing below those two published values on average. We also have a range of farms that are above that as well. So another thing that we're trying to do through this work is identify what good practices farms are already doing in New York. One, to acknowledge the good progress that has already been made, and also to try and see what might be driving some of those lower greenhouse gas emissions, those lower footprints. So what the farm gets here, this blue bar in the middle is their current practices. And then moving to the left, we look at beneficial management practices that have already been implemented on the farm. So in this example, the farm has put in a manure separator and they're doing some reduced tillage and cover crops. And that has brought their emission intensity down by 9%. So in the red bar, that 0.82 is where their footprint would be if they weren't doing any of those beneficial management practices. On the very left, the 0.98, as if they were importing all their feed. No homegrown feed. We know that in New York, we saw from the mass balance results, on average 65% of feed is homegrown. If farms weren't doing that and they were importing everything, their footprint would be much higher. And this again, the calculations done to estimate that they're based on book values for crop production. It's showing how above average New York farmers currently are in terms of crop production. And this is a way, so for an individual farm, we can identify what good practices they're doing, encourage them to continue doing them. But as we grow this data set, we can look at the larger scale as well and see for this particular type of farm, what things are helping to bring down their footprint. As we move to the right from the 0.75 to the 0.61, these are additional practices the farm could implement on the farm. So here we look at an ideal world, an ideal situation, saying, okay, if the farm went 100% cover crops and 100% no-till and they put in an anaerobic digester, where could they get to? So on this farm, they could reduce their emission intensity another 24%. So we know this isn't feasible on all farms, but we want to show what potential there is and, some of how they could move towards that potential. And also try and get a bit of a realistic idea on what is feasible with the current strategies available for farmers. On the very right, we have that feed additive, what we're calling a speculative opportunity at the moment. So enteric emissions, we know that's a huge part of the footprint, approximately 50% on a lot of farms. It's something that we need to, in the future, we're going to need a solution for that. Right now, there isn't any feasible options available, but down the line, it's something that might be there. We want to focus at the moment on these yellow practices, the things that farms can do, and they hopefully have wider benefits on the farm as well, improving soil health and crop yields, maybe benefits for water quality and things too. So we've done that for greenhouse gas emissions. We would also like to extend this to look at biodiversity, but currently there's a lot of questions around this. So what scale do we need to look at? Do we want to look at the field or the whole farm? Are we looking above ground or below ground? And we're going to need technologies to help us get there. This could also be a way that farms can move towards greenhouse gas targets through carbon sequestration. Another thing to think about is water. So what is the water footprint of New York dairy? We've always thought, okay, we don't need to worry about this because there's almost no irrigation of crops, particularly of the forage crops. But maybe this is another thing we could start to look at for New York and see it as an advantage for the dairy industry here. The fact that we have a very low water footprint. And again, we want to start to link those sustainability metrics. So, farmers are being asked a lot of things. We're hoping that by linking together the mass balance and the greenhouse gas emissions, we can, that whole minimum input with maximum output, running the two assessments together and helping to get combined results out of them. We also know feed and fertilizer are the biggest drivers of the mass balances. They also seem like they are a driver of greenhouse gas emissions as well. And we know that they have an economic cost associated with them. And we know that a lot of the beneficial management practices that are being promoted for reducing greenhouse gas emissions also have a cost associated with them. And we want to acknowledge that when we're looking at these potential opportunities. So there's a lot of talk about reducing greenhouse gas emissions. At the moment, it's all voluntary, but there's some big companies also interested in that. So Nestle, Starbucks, Ben & Jerry's, Chobani, these all have an interest in bringing down greenhouse gas emissions. And by taking part in these assessments now, whilst it's voluntary, you can start to see where your farm sits and what opportunities you might have. Okay, so here's a farm that has been taking part in the assessment for a while. I'm not sure if you're able to hear the sound.
We're not hearing the sound. I don't know if Julie has any quick fixes for that or.
Do you have permissions turned on your computer, Olivia?
Yeah.
Or is there a link and I can play it through my computer?
1 minute. I think we might have to skip the video, unfortunately. So sustainability tools. Why should farms want to take part in this? Why should they want to voluntarily take part? you know, they get a lot of value out of it. We talked about benefits such as decision support and on-farm efficiency. And it also contributes to environmental protection and enhancement. Additional benefits. Could this be a market advantage down the line? Could it be used to inform consumers and guide policy? You know, by looking at those waterfall figures and seeing what is feasible and what is potential opportunities there are for farmers, we can make sure that any targets are actually achievable and reasonable to expect farmers to achieve. I think a lot of it though is by like now, if you take part, some of the farmers that have taken part with us, they've been surprised at how low their footprints are. They were worried about it. And I think that is another reason to take part. Just find out where you are and is there something you can do? If you are interested in taking part, this QR code will take you to our webpage where you can find the data input sheet. And if you did submit your data to us, you would receive an individual report for your farm's NP and K mass balance and greenhouse gas emissions. You'd be able to compare yourself to other New York dairy farms. And you'd also get that opportunity table and waterfall figure to identify areas for potential improvement. Another thing is you can help us grow our database. So all this data is anonymous. And we can start to look at what different types of farm, what good things they're already doing, what opportunities they have, and how we can help inform management decisions on those farms that are going to both bring down greenhouse gas emissions and hopefully improve productivity and efficiency on the farm. So in terms of that anonymity, so we have a policy at Nutrient Management Steer program where we don't identify farm names or share individual farm data without the farm's permission. Data from individual farms is always aggregated, so your identity is protected, and our aim is always to improve nutrient management and greenhouse gas emissions in this case. There's also a link here, you can see the full document on our website. So with that, I want to say thank you, particularly to the farmers that have already taken part, and you know, they're planners and nutritionists, consultants that help make this all possible. And you know, we want to really grow this initiative, but we want to make it beneficial both for you as the farmers and for us.
Thanks so much, Olivia and Q. That was really super. And you guys finished well ahead of time, and we have lots of opportunity for questions. I'd like to start with the questions that are in the Q&A, and I encourage folks, if additional questions, if you have additional questions now, please go ahead and type those in. Want to thank one of the participants, Juan Ramos here, who has posted the link for that Olivia wasn't able to play in the Q&A. So anybody that wants to see that on their own can go ahead and grab that. Let's start with, I see Joanne Knapp has a question about how many hours does it take to collect and enter the data into Cool Farm tool and prepare the report on average for the farms?
That varies a lot between farms. You know, it depends on the records that they already have. Some farms are able to get the data straight away and send it to us to run. Also, you know, a lot of it runs on how the imports of that farm. So if it's a bigger farm with more complex management, there's a lot more things to put in there than a smaller, simple farm. So I'd say it really varies on farm. It's hard to put an exact number on it. Part of this process as well is we like to make sure that the data that is going into these tools is correct and accurate. Like we said before, if the data is not good going in, we're not going to get an accurate result out. So sometimes there is a little bit of back and forth between the farm and us to make sure that we have good data that's going in, and that can extend the process as well. But go ahead.
Yeah, I was just going to say, Olivia, isn't it true that sometimes the first year is a little bit of a heavier data burden, and then if farms are able to, if there are modifications needed in how they track things through the year, that makes that next year much much less complicated. And
Yeah.
but it's a handful of hours, right? It's not days.
Yeah. Oh no, it's not days. And I would say as well, a farm, if they're worried about the burden of the data collection, is still get in touch with us and see exactly what we need. And yes, you might not have the right data right now, but you can start putting that record keeping in place so that it is easier down the line.
And a related question here is, are the producers entering in their own data in Cool Farm Tool, or do the researchers do it?
We do it. Yeah.
And why is that?
So one, again, is that we want to make sure the data going in is accurate. And currently, some of the things within Cool Farm Tool could be interpreted differently. So we want to make sure all the data is going in the same way. So everyone is being assessed equally. And yeah, there's no misinterpretation of what is being asked for.
Yep.
And also, sort of, you wouldn't get some of that later analysis as well with the waterfall figures and seeing the impact of different beneficial management practices that can't be run through Cool Farm Tool by an individual user.
Yeah, I think we can't emphasize enough how important it is to have the folks doing the input to be relatively calibrated, so that they're answering the questions or data gaps in a similar way. If you're going to compare yourself to others, that's a really important piece of this. Okay, so that one's done. Let's switch over to Q a little bit. Let me see here. Sorry, let's see.
I've been answering questions along the way.
Yeah, maybe that's why
I might have taken them out.
Good, that's why they're disappearing then. Okay. So there's one in here, Q, that you didn't answer, that's with P use efficiency improved. How does one manage the HABs in water bodies that might be associated with high animal density farms?
So part of the reason why we do these mass balances is that it's not necessarily high animal density farms that have the higher balances. So one of the things a higher animal density farm can do is find ways to export manure and therefore lower their balance again. It's definitely an aspect to look at on an individual farm basis. And it's also definitely not the case that there's a direct link between the balance and the occurrence of HABs in a certain water body. It's a lot more involved in that. What we are trying to do with these mass balances is give a farmer a sense of how they compare to other farms, and to give them some tools to see, are there opportunities for improvement? What can I do to be in the green box over time?
There's another question, Q, that I think you could cover in terms of what agronomic testing methods were employed.
Yeah, I saw that question, and I'm not sure exactly how I need to interpret that question. With both of the assessments, we basically look at what the farm submits to us in terms of what their agronomic practices are. So we have a diversity of farms, from small to large. We have no-till, reduced-till, conventional till, low animal density, high animal density, low production, high production. So the database right now reflects that diversity. And this is also the reason why we want to grow the database and get more farms involved, so we can have a really bigger snapshot of what happens in the state of New York as well. I don't know if there's another way to interpret this question, Carl, if you have any.
Yeah, I mean, maybe Zach could have put a follow-up into the Q&A section, but it strikes me, I mean, our nutrient management plans are based on the Cornell guidelines. So be either the Morgan test or the Malick 3 test and the relative conversions. And I would say that the job that folks are doing with their nutrient management plans in CAFO, and for farms that are in a voluntary nutrient management plan, that also tells us that our guidelines are doing a good job of, supporting crop production and not building up soil levels extensively. Another question here, is there a long range goal to have this usable by advisory and consultant or consulting folks?
That's already in place.
Yeah, do you want to say more about that, Q?
Sure. Yeah, so there was another question I replied to. The mass balance is an assessment that's open to anybody. We have a software tool on the website. You can download it yourself. Obviously, we get a lot more value and we can help you troubleshoot if you connect back with us on those assessments. But that tool is already used by individual farms, by farmer groups, by consulting firms with their clients. It's already in place. And as we presented, about 21% of the milk in New York is already going through that assessment. Cool Farm tool is going through a similar process as we went through for the mass balance, but that's a software tool that's online. And as Olivia mentioned and Carl mentioned, it requires a little bit more of expertise in terms of what you enter, how you enter it. So the data consistency for use there is really important. There are farmer groups that have come together and are using this with a designated person on their team. But for the projects right now, people are coming through us based on, and the results we presented are based on what Olivia has put through the tool.
Thanks, Quirine. There's several questions that go to, can the tool account for this or that, feed additives, biochar, some other things? Maybe, Q and Olivia, maybe this would be an opportunity for you to talk a little bit about, how you're interacting in this case with the Cool Farm tool folks, and just, for any tool, how do we deal with these practices that we think have impacts on emissions, and what's needed and to get that into a tool that you could actually, quantify.
You want to take that one, Olivia?
Yep. I can chip in if you want to, Quirine. But yeah, so Cool Farm tool, one of the things that is nice to work with them. So I'm on some of their working groups, Quirine is on their science advisory committee. They are very interested in being able to put in these new feed supplements, and they have been talking about biochar as well. But they are very concerned that the science must be robust before they will include anything into the model. And so this is, they do have Bovaer in there at the moment, free NOP. But there's other feed additives. There's even just some management practices. Until they are sure that the model behind it or the science behind it is robust, and they're confident in the results that it gives, they won't build it into the model. And I think, this can be frustrating at times. We want to be able to model these new things and see how they're impacting on emissions. But at the same time, it's reassuring to know that they go through quite a rigorous process before they will include something into the tool and make sure that they are confident in the results that come out. And they're also very open, with these working groups, they have farmers in those working groups. They have representatives from the companies that use the tool. They want to know what practices go in there and how we can, what we as users want to see improved in the tool moving forward.
Yeah, that
ahead,
really
Q.
gives us an opportunity here to really work with farms, go through these assessments, figure out where would we want to make changes, where would we want to see something else incorporated, and then bring it back to the committees and to the Science Advisory Board for discussion. I'm really impressed by how they put the emphasis on ensuring integrity and robustness of the methodologies. And that causes things to be a little slow in development, but it is really important.
Excellent, thank you. There was another question about, will this be shared? And Julie, this is being recorded. This will be posted on the ProDairy website. Is that correct?
Yes, and after this webinar wraps up, you'll receive a follow-up email with the link. But you can also navigate to the ProDairy website and click on our events tab and go down into webinars, and it'll be posted there. And I'll also post a link to the video.
Excellent. And then I want to put a plug in for, you've got this QR code here. So anybody, you know, on the webinar today can take a picture of that, and they can learn more about if they want to participate with their own dairy farm, for example. Is that right? So
Yeah.
I just wanted to make sure that people are clear on that. There is a question that I want to address. Do I think analysis or reporting like this will become mandatory in order to ship milk? I think we're probably heading in that direction. We're not there yet, but certainly the extent of there's certainly an expectation that more and more farms will be doing it, and I think that's why this team has started the process and is inviting more dairies, you know, who want to know what their carbon footprint is. So I don't know if or when it'll be mandatory, but I think the dairies that are planning for the future are going to take a look at this, see what their footprint is. Maybe they find out they're in pretty good shape. And what do they do next? Or maybe they find out they have some work to do and they'll have more time than if they wait before getting in, you know, building on this knowledge base and understanding what their footprint is. I don't know, Olivia or Q, if you have anything you want to add to that, but, you know, we're not in the regulation business, obviously, so we're not the ones that make that decision, but there's certainly signs that companies that buy milk products are going to want to know more about on-farm emissions and want to see significant reductions. No other comments there. So I want to thank everybody for joining today. This hopefully you got quite a bit out of it. Q, did you have something more you wanted to say there, or nope, you're good? We are at the top of the hour, and again, want to thank you all for joining. We are going to have another session next week on funding opportunities to maybe help with some install some greenhouse gas reducing practices, and look forward to seeing a number of you next week, or hearing from a number of you next week in that session. Thank you, everybody.